Welcome back to another fantastic week of the Cinema.Engineering podcast. We are gathered again this week to talk about some very, very cool stuff in the same vein as what we've been discussing previously, based on standards, no BS, no snake oil, and no advertising. So this is a fun-filled two-part session, which we'll be starting today talking about what makes up great audio. What makes a great loudspeaker experience? What makes a great stereo setup? What gets your feet tapping when you sit back and you listen to music or when you watch a movie? What facets go into that recipe which brings you the experience that you want? I'm joined again this week by the fantastic Peter Aylett, Ben Goff, and Owen Maddock from CinemaWorks, Cinema Luso, and Officina Acustica. Peter, fire away.
Before we start, I want to make Ben blush. Those of you in the know, which is probably most of you, probably already know that at the recent Cedar Awards, Ben not only walked away with the gong for the best EMEA cinema in his category, but he also walked away with Best Cinema Global. So that is, in the judge's opinion, all of the cinemas at all of the different price categories, Ben was awarded the best cinema submitted in the Cedar Awards this year, which I think is kind of a big deal. So if we can give Ben a quick clap, that would be fantastic. Well done, Ben.
Thank you.
Take that kudos. I don't think your camera's quite got the color resolution to show that blush, but you know, I'm hoping it's there. You're looking happy.
Post visual effects. I'm sure we can edit something in.
There is a trophy and stuff. I mean, I have got the global one sat here on the desk.
We can leave you to go through all the details, Ben. But I think when we talk about the stuff we have so far on this podcast, it's fantastic to see, and it's very well deserved, that an award has gone to a cinema that was designed entirely based on standards, objective replication of something that the customer understands. And you've got a fantastic story to share as well about a very late night at the awards, followed by a very early morning drive to a Trinov interview. So
yeah, that was not necessarily the brightest idea to do that on 2 or 3 hours sleep, but hey, it was good. And yeah, it was great. I was really pleased. The presentations at the awards, when we won both of them, they focused on, you know, the understanding and the meeting of standards. You know, when we won a year ago, there was a lot of talk in the room. It was a very pretty room. It was a great looking room. There was a lot of talk. You know, it was the photos that had won it, and this year it was definitely the standards, and that was really clear. So that was cool for me to know we'd won it for the technical merit.
So speaking of technical merits, what makes up a good sound system? What can we dig into to speak to our audience and indicate to people what recipe to use to combine things to make a great experience?
Can I kick off on that, Christian?
Yeah, absolutely.
And I know we're probably going to be a bit boring as a group in times to come, because we're going to be constantly referencing, funnily enough, standards. So I'm going to be referencing some of the work that we're now doing in the upcoming RP22 standard, which is the recommended practice for immersive audio design. And when we were thinking about how to structure the document, we thought we need to structure all the different technical parameters in a way just to make them a bit more understandable and a bit more segmented. So we came up with a concept that puts great sound into 3 chunks. The first is dynamics. And the simple way to describe dynamics is A, what is the quietest thing that the system's able to reproduce and you're able to hear? And secondly, B, what is the loudest thing that the system can reproduce and you're able to hear? And both of those within parameters, because when it goes loud, there's no point it just being loud and it being horribly distorted. You know, it's still got to sound good. And when we say good, the second element is something that we call timbre, spelt Timbre. Some people say timbre. I'm a bit old school, so I say timbre. You can say what you like. And timbre is really that a Stradivarius should sound like a Stradivarius, a Steinway piano should sound like a Steinway piano, and you should be able to tell the difference, as my great friend James Chen can. He's incredible. If you listen to some piano music, within 3 or 4 seconds he'll go, "That's a Steinway," or "That's a Bechstein," or "That's a Bosendorfer," and you look at the sleeve notes, and every single time he's right, but he's a pianist. So timbre is just the system's ability for when something is recorded to be played back and sound. I'm not going to use that word that begins with A, and we'll talk a little bit more later. You all know what word I'm not going to use, but we want instruments to sound like instruments. And the third is spatial. So in the two-channel world, if you're listening to a pair of speakers, those speakers have got to image. In other words, present a soundstage where the speakers, disappear. So you're not listening to two independent speakers, you're listening to a complete soundstage. In a multi-channel immersive audio system where you've got lots and lots of speakers, that's kind of a combination of two things. The first one is immersion. So immersion is just that you are feeling that you're sitting in a soundscape. Again, the speakers should disappear. If you bring someone blindfolded into the room and say, "Where are the speakers?" they shouldn't be able to point to them. However, the other side of that is that if the sound engineer, the director of the movie, intends a sound to be coming from a specific place, then the system needs to reproduce that sound in that specific place with a high degree of correlation to the way that the content creators intend. So that's dynamic range, timbre, and spatial.
So yeah, that gives us a good overview of the whole system based in three fairly simple criteria. But I guess if we look at dynamics, dynamics is interesting because it's one that people relate to the easiest. Everyone knows when they think a system's too loud, right? Or if a system, volume is a really easy concept for everyone to understand. But I guess how many people understand quiet, the opposite end, like a really quiet room? We've all been in anechoic chambers. We know what really quiet is like. But I don't think the general public or many of our clients know what happens when you start with a really quiet room. And that's quite an exciting part of getting that dynamic range, is not just getting louder and louder with the output, but starting quieter and quieter at the bottom end to get that. And that it's effectively like contrast ratio in video, the difference from black to white, the difference from loud to quiet. Loud's rubbish. It doesn't do anything without quiet.
If the viewers of this, I think, can take one single thing away from this podcast, is that the industry seems obsessed with, let's just get another 3 dB at the loud end. Let's just make it go a bit louder. I think the industry needs to start getting even more obsessed with saying, how can we make that room quieter and quieter and quieter? Yeah. Because sound just coming out of a completely black, quiet background is beautiful. And a quiet room is appropriate and beneficial no matter how loud you listen to your system. It's just beautiful. That last 2 or 3 dB at the top end, is that worth it? Sure. For a lot of content it is, but also for a lot of content it just isn't.
There was an interesting conversation we had with one of our colleagues, Rich Green, a couple of months back, and it's kind of unrelated to directly the audio side of things, but it is intimately relative, because it was a conversation based around health and humans and around what we experience. And it went down the path of a background noise being introduced into homes through air conditioning systems, through stuff attached to the building, through vibrational energy coming into a residence. And if we think about all the stuff that's around us that's constantly noisy and in the background, and what we have to mentally tune out all of the time in order to just work through, having a very quiet room or a quiet space is, as you've just indicated, it's a beautiful blank canvas to start from. And I think one of the things that we, outside of the scope of audio, need to do more often is sit in quiet and really allow ourselves to focus on the things that we do without the distractions. And that analogy effectively could be very, very suitable, and is very suitable to how we experience good audio.
So we're about objectivity and standards. Who wants to put some numbers next to what is quiet?
Real quiet is obviously threshold of hearing. It's not impossible to make a room that is at threshold of hearing. It is, to all intents and purposes, silent. But in a lot of our projects where budget doesn't allow that, we need to get to a level. So maybe NC 20. So the NC a rating because we're less sensitive to bass than treble. So if we pick an arbitrary level of 20 decibels, 20 decibels of bass you can't hear at all. 20 decibels of really high frequency hiss from an air conditioning unit would drive you mad. So the NC gives us a curve that essentially says bass can be loud without us noticing it. But that's starting to be quiet. NC 20 is a pretty quiet room. Coming below that, we get to a point where 99% of people in the room would never ever be distracted by background noise. And that, so the opposite of quiet, if you look at a projector that is 35, 40 dB from its fan's output, hang that directly over the client's head on the back row, you could easily have a noise floor just from a projector of over 35 dB at that seat. So
does this help?
There we go. Very
Explain what you're talking about. That's starting at NC 15.
So yeah, NC 15
and I think
is pretty cool.
I think the interesting thing to say about NC is that when you say how quiet's your room, if someone gives you just a single number, they say, oh, it's 25 dB or it's 20 dB, the chances are that that's going to be weighted. When we say it's 20 dB, we don't mean it's NC 20, because just a single number tells you nothing about the spectrum. And actually, you could have a very audible bit of noise at one particular frequency, but the rest of the room be really, really quiet, and you end up with a very, very low single number noise floor, so 20 dB for the room. The reason that NC is so useful is it shows you what the noise is, all the way from around 60 hertz up to 8K. So, and it also shows where we're kind of more sensitive, which means that you're allowed a lot more low frequency than you are high frequency. And all of that low frequency noise, that's just going to be movement of air. So if you've got air conditioning, if you've got fans, and you're moving the air in the room, the microphone's going to pick that up. But you're allowed some of that movement compared to higher up in the frequency spectrum, where you're allowed a lot less noise.
Peter, as an example, with that chart that you've got on there, for those who are watching and or listening, a rated level of noise for a bedroom when you get disturbed at night while you're sleeping is roughly 30 dB. Where on that chart are we looking at that sort of number, and what coefficient are we looking at in terms of a frequency?
I'm going to force you to do an edit here, Ben, because I'm going to run downstairs, grab a microphone, plug it in.
Yeah.
So at least then we can see what this looks like in just a normal room. Well, I'm just going to plug this in and see what happens.
Cool.
Show you the noise in this room. This is like the old days when I used to teach networking and everything went horribly wrong.
We're freewheeling here. This is great. I guess one of the other discussions that we need to have, or we need to start at least having people understand, is that the NC measurement is different from the noise. The noise coefficient is different from the measurement of noise in the room, which is different from the way that noise is absorbed and the sound transmission coefficients that we work with. Oh, pretty diagrams.
So when we talk, there's loads of noise in Peter's room because he's got speakers on. But your room's not that quiet considering we're recording in it.
It isn't.
So that's
But then there is a reasonable amount of background noise coming out of my speakers.
yeah.
Well, that's our fault.
It is.
We'll all be quiet for a minute. So you're at, where are you hitting? NC 50?
No, we're currently, well, I mean, as I'm talking, it's a bit difficult to read. So let's get rid of the peak. And if we all be quiet for a second. So that's just above, when I wasn't talking, that was just above NC30. So that's the noise floor in here. And I reckon if I press the mute button and muted the little bit of noise coming out the speakers, that would take it down. But on a quiet day, I've measured in here, it's about NC23. And you can see that spectrum, that there is well, with me speaking, it's kind of irrelevant, but there is some noise at about 100, 120 hertz. And I think that's just some background noise coming out of the speakers as a result of this call. So all I'm using here is a quite simple calibrated USB mic made by a company called Mini DSP. They do a less expensive one that's about 100 quid. This one's about 250 quid. The big advantage of this one over the cheaper one is it's a lot quieter. So this will measure down to about 20 dB. Its noise increases considerably above about 12K, but for this kind of measurement, that doesn't really matter. So you should be able to get decent NC measurements with this down to about NC20, NC22, 23, which is a really quiet room. Some of the rooms we engineer are going to be engineered to be even quieter than that, but you need a much more fancy, much more expensive mic.
So below the low cost UMIC mics, for USB based mics, to get really low noise floor measurements, you need pretty specialist equipment, kind of lab grade equipment. So, we would have one microphone. We use multiple microphones when we're doing seat to seat consistency, and we've got several on different seats. But for that noise floor, there is one mic that we've got that just gets us down to those low noise floors. And yeah, it's an investment. If you're going to build rooms that quiet, you need to prove it, you need to measure them, and it's special kit. So for most people, that is probably excessive, but for the really good rooms, those really quiet rooms, you need cool kit.
So we're spending a huge amount of time on what is good sound, and hey, we've even done some live quick measurements on just noise floor. But let's put some numbers against this. And what you have to consider is if we're talking about a cinema here, that cinema might have some pretty noisy things in it. The most noisy probably being the projector. And if you've got a projector hanging on the ceiling, whirring away above your head, that is likely to dominate the noise floor of the room. So in the recommended practice, what we're basically saying is NC30 is really the minimum acceptable. If you're going to a much higher performance room, you're looking at NC25. If you're looking at anything that you consider that, this is a really high performance cinema, you really are looking at NC20.
And when you start looking at specifications, you start looking at the marketing pamphlets that a lot of these projector manufacturers put out, and those numbers that they rate the projector's noise output level at are most likely at a low lamp light output, at a low altitude output, and running in a perfectly cooled, ventilated room. So they are trying to make sure that the numbers indicated are very, very low. But you're going to see numbers like 35 and 37 and 38 and 42, which, when you relate it back to what we've just looked at, that's quite noisy.
And of course, then when they're quoting the brightness of the same product, they're ramping the thing up in terms of light output, which is going to make it an awful lot louder. So even the often the own specs will kind of contradict themselves. They're going, it goes this bright and it's this quiet. Yes, but not at the same time.
Exactly,
Sway.
exactly. So we'll dig into all of those with your fantastic room that you've got going now, finally, Owen. But Peter is itching to carry on because I guess we've covered a part of dynamics, which is sound isolation, and we've touched on that background, and that actually lends itself to many aspects on the rest of the sort of pie chart that we've got in terms of your three main facets.
So we've talked about how quiet it is. Let's talk about how loud it needs to go. What's reference level, Ben?
Cinema standards would suggest 105 dB from all screen channels. I think commercially Dolby let you have 2 or 3 dB reduction to surround channels. Subwoofers need to be 10 dB up on that, measured at third octave.
And that historically has come from the old school 85 dB measured at the listening position amount with 20 dBs worth of headroom.
Correct.
And this is something really interesting because there's a gulf between cinema and music here. That in cinema we've actually got some numbers. In cinema, when they're sitting and making the content and mixing and mastering it, they know exactly how loud they want it delivered. And the standards are then written to say, well, you need a system that can deliver these peaks, with reference level being exactly as Ben said, 105, which is 85 with a 20 dB headroom on top of that for all of those dynamic blasts and explosions. In music, well, what does reference level even mean? You know, are you down the pub, standing at the front with a Motorhead tribute band, with all their amplifiers turned up to 11? That's going to be a lot louder than 105. Or are you sitting in Wigmore Hall in London listening to a chamber quartet? That's going to be a lot less loud than 105. So really, when we're talking about music, there, you know, it's the Wild West out there in terms of how loud does it want to be. And there's a couple of quite interesting companies that have recently got into our world that come from a live music background. And you know what their whole selling point is, our systems can reproduce the dynamics of a really, really loud live concert. And for a lot of music, that's really important.
Yeah, I guess there's dynamic range inside the content as well. So if we say that peak output from a main channel is 105 and the room is 20 dB at its noise floor, the maximum we can hear is that 85 or 80 to 85 difference. In music, that difference just doesn't really exist anymore. I think we can go back 20 odd years and look at when the loudness war happened, and dynamic range has been compressed and lost in the production stage. That slowly music has crept. The average volume has got louder and louder, so that it stands out on a jukebox, it stands out on the radio. But there's,
I mean, they do still make classical, Ben, but I'll take your point.
Sorry?
Yeah, I was
music.
going to say, I think your fundamental, yeah.
Pop music doesn't have the dynamic range. But I mean, obviously, classical music that predates loudness war era is huge dynamic swings. But pop music is, I'd be surprised if a lot of pop music's got more than 25 dB of dynamic range. It just, it's really samey. It's just the same all the way through.
You know, when you're in the site phase on a cinema build and the guy's got his DeWalt and Makita radio and it's got a drive unit that big, all modern pop music is designed to sound sort of acceptable and pretty loud on that site radio or in, you know, the worst van radio you've ever heard. It's
you've
just
had recent experience with that,
so
haven't you, Owen?
A little bit. Can't remember what.
To actually I wouldn't say challenge the discussion so far, but in obviously the pre-production, post-production, that whole industry for music and TV, they also do work to a specific scale, and I guess there is an overlap because LUFS or units of audio loudness relative to full scale is what they use, and there is as part of that, what you've just indicated, Ben, the loudness wars, there is a measurable standard that they have to adhere to in order to deliver content to a broadcaster or to put content together for an advert. to master some music. And all of that stuff in the production chain goes in to the point where we finally stream it on a device or a platform. And then we have to gauge what that relative dynamic headroom is. Because as we've always said, if you put rubbish in, you're going to get rubbish out, just amplified. And that adds another level of discussion to this multiple facet.
There's a very famous piece of recorded classical music, which is Tchaikovsky's 1812 Overture, and it's a Telarc recording, and it's got about the widest recorded dynamic range on a disc, on a recording, on a file. And it is quite striking that you're listening to this and you think, oh, this is quite loud. And then, I don't know if you know the 1812 Overture, but it's got cannons in it. And then the cannons go off and it's, whoa, catch that tweeter as it flies overhead time. And, you know, to what Christiaan was talking about, the 0 dBFS, 0 dB full scale, needs to encapsulate the entire dynamic range of the recording, including the cannons. So most of the recording is nowhere near 0 dB full scale, like it is with a lot of pop music. It's, you know, minus 28, minus 30, much, much, much quieter. And that's where our previous discussion of a really, really quiet noise floor comes in. That's especially important for listening to instruments recorded in a space. You know, electronic stuff, it's not really being recorded in a space. Microphoned instruments in a space, you want to be able to capture all of those little low-level details, all of the cues that tell you something about the space, even though you haven't got a picture. It's so important to have that low noise floor.
So an interesting one is how loud is too loud. So we know we've got this reference playback volume, and I know a lot of people in the industry will say the clients don't like to listen to things that loud. So I would challenge that and say clients don't like distortion. Distortion is unpleasant. And when we push a system that shouldn't play to 105 with 3 dB of headroom to keep it free of distortion, it sounds unpleasant. So if we go back a couple of weeks to Expo, Peter was involved in what was widely regarded as the best room of the show by a fair margin. I saw quite a lot of that queue that people waited 2 hours to get in. Every single person came out, said it sounded fantastic. Nobody said it was too loud. Nobody thought it was too quiet. Everyone said it was great. So how loud was that room, Peter?
It was reference level. It was 85 plus 20. We were playing that at deliberately reference level. We did not choose that level. We set the 85 as our reference level, and that was measured. And then there was 20 dB headroom above that.
And nobody came out of that room saying, "Oh, that was a bit loud. I wish turn that down." That was the correct volume, and everybody enjoyed it.
It was the correct volume. When people were speaking, they were at a volume level that someone would be when they were speaking that far away from you. But in a Top Gun scene, when there are 2 jet engines on afterburner, that was much, much, much louder. And that's what we're talking about with dynamic range. There is a correct volume to listen to that content on. And the best way to tell what is correct isn't when there's music, or isn't when there's action, or isn't when there's gunshots. It's just a couple of people sitting at a table at a cafe having a conversation. And you listen to that and go, is that the kind of level that they would be in real life? And just because it then gets 30 dB louder than that when Arnie then drives his motorcycle through the brick wall, well, it's meant to be 30 dB louder than that. There is a correct volume level. Now, it wouldn't necessarily be right to turn that up, because then you're probably going to stress the vast majority of systems out there. And if someone chooses to turn it down, that's up to them. But what then sometimes happens is voice intelligibility suffers. So people can't quite understand what's being said. And that's just the glory of uncompressed full dynamic range audio.
And
Yeah, back on sort of planet Earth. Having recently acquired a cinema I can play on. What was interesting was I started it off kind of at -10 from reference and so on, and I just basically left it alone for a bit and just started riding the volume without anything on the screen until it felt right, until it felt comfortable with a load of stuff. And I know there's a decent amount of headroom in because I did a bunch of sums before I put it together. -2, pretty much, and it just means it's clean. Yeah, because I was always the person who's going, oh yeah, -10, that's a bit better. Because earlier in my career, going back 15 years ago, working in shops and whatnot, we would probably mismatch the systems, and there would be a point at which it would start to distort, and that's what people mean. I think when they say we don't like it loud, they go, yeah, we don't like it when it starts to break up and sound awful. But when it's clean, it's not a problem.
No, it wouldn't be a podcast without a car analogy, would it? It was. So I've got to throw a car analogy out there, and that is if you want to legally, of course, drive around on the motorway at 70 miles an hour all day, don't buy a car that's got a maximum speed of 70 miles an hour because it's going to be horrible.
Yeah.
And also on the other side of that coin, just because your car can do 150 doesn't mean you have to drive around in it at 150 every day. It just means that when you're doing 70, 80, 90, however you want to drive, there's just a sense of ease and relaxedness. And bear in mind that with audio, if you go down 3 dB, which is, audible, it's not a night and day difference, but 3 dB is audible. That's half the amount of power.
Yeah.
So to 3 dB sound pressure level is equal to double the amount or half the amount of power that the amplifier is delivering. So it's really, really important that when systems are designed, if you want to achieve 105 dB, you should really be designing a system that A, has got the capability of doing 108 dB, and ideally, although this can be both expensive and difficult, that you're leaving your amplifier with 3 dB headroom. In other words, it's being specified as twice the amount of power that you need. And something that a lot of people find surprising, you're more likely to blow up a pair of speakers using an amplifier that's underpowered than using an amplifier that's overpowered. We should probably do a little Mythbusters on that one day, just to go into that in a bit more detail. But if you clip an amplifier, in other words, you're asking the amplifier to provide more than it actually can, that is really, really painful and quite destructive to a pair of loudspeakers. So, always design systems with headrooms. We're 35 minutes in. I think we should probably move on from dynamics and start talking about timbre. So, timbre, who wants to kick off with describing what timbre is?
Go on in, Owen.
Oof. Yeah, well, I'll have a go. If we go back to, can you tell the difference? And I will not tell the difference between a Steinway and a Bosendorfer, but I can probably tell you a Stratocaster from a telly, because that's blatantly easy. The telly's got a certain spring to it, so there's a certain character.
A certain je ne sais quoi little spring to it.
No, just the one's got springs on the bridge, so it doesn't have anything like as much attack on the strings if you hit it harder. But and you can hear that. That's super easy. You just need to be used to it. That's not clever. That's just a function of experience, I suppose. All right, so there should be a certain character to the way things sound, and it shouldn't be added by the audio system if that's at all possible. And again, it's hard because then we sort of veer into the A word. But I think you can be accurate to one thing, which is, and certainly when we're playing music, you can be, which is you can probably be accurate to what the bloke signed off on in his ear. And if that's happening in your ear as well, then that's probably about right. So I think it's about the removal of character from the audio system, if that makes sense.
I heard a great story from the head designer of a very, very well-known audio company, where at a show he'd just finished a demo, and one of the public came up to him and said, I don't like your speakers at all. Don't like them. They have no character. And this audio designer said, "Oh, no, thank you very much. That's the nicest thing anyone said to me all day." And he's absolutely right. And in the world of hi-fi, what I think people do is people tend to choose the most pleasurable distortion, because all audio systems, and you've got to include the bit between the loudspeaker and your ears as part of the audio system, and that interface between the loudspeaker and the room is the point at which by far, I mean, all you tweaky geeky audiophile types, you can argue over the 12th significant digit of intermodulation distortion between your two favorite DACs. All of that pales into insignificance compared to the effect of the room. And when people listen to speakers, especially, what I think they're choosing is that they're not choosing the most transparent or the most, I'm going to use the A word because you just did, Owen, the most accurate. What they're choosing is the distortion that they find most pleasurable. So our job, and ultimately timbre, is the art and science of removing distortion from the entire signal path. So a digital signal path, an analog signal path, and then an electroacoustic, and then just mechanical acoustic signal path.
By definition, is the quality or the tone that is given to a musical note and the reproduction of that musical note. And we all have different ears, we all have different taste buds, we all have different eyes. Everything is going to sound different to each of us, and there are many degrees of difference relative to the room that you're in, the furniture in that room, the 0.0000% distortion on whichever different DAC you're using, in which day, depending on the phase of the moon and the alignment of the planets. This is the level of detail that we go to. But in essence, it's exactly as you say, timbre is the way that it sounds and the perceived way that sounds on a scale of quality or on a scale of color.
And you talked about a musical note, Christian. A musical note has a fundamental, and then it has a series of harmonics, and all of those add up to what you hear as a musical note. And if any of those are wrong, so let's say you have an inaccurate frequency response, and one of the harmonics is 5 dB down compared to where it should be, it's going to sound different. Let's say you've got some really bad group delay, and from a time perspective, those harmonics are reaching your ear at ever so slightly different times. It's going to sound different. So yeah, it is about accurately, I've used the A word again, but as transparently as possible, reproducing everything that is in that encoded information throughout the whole signal path. I find it amazing
that the Greeks were able to do this and build amphitheaters hundreds of years ago without all the tools that we've got, and yet here we are.
Absolutely.
So that discussion distortion is interesting. I think if I won the Euro Millions tomorrow and had unlimited budget, I would have multiple 2-channel systems that each of those rooms would probably be where I'd listen to different types of music. There are definitely hi-fis I've had over the years that play some things great, but when you want to get down and listen to some dirty rock music, it doesn't really work. When you crank it to those volumes, it just doesn't work. So there might be a system that behaves well for different things, but the cinema wouldn't be that way. The cinema is as, I'm not going to say the A word, the cinema is evenly distorted, and the timbral accuracy is there, that it doesn't matter whether it's for dialogue or explosions. If it's fireworks, cannons, cars, planes, they all sound as I'm expecting, as the engineer expected them to sound. So I would build a cinema different to a hi-fi, and I'm okay with that.
I wish we had a can of worms icon that we can put on the screen now, because I think you've just opened a huge one, Ben. Because certainly with loudspeaker design, generally when you make something else one thing better, you're probably making something else worse. And it's not difficult to build a a very transparent, very detailed, very well behaved speaker that doesn't go particularly loud. It's very easy to build a speaker that goes tremendously loud, but has all kinds of different types of distortion associated with it, like cheap PA systems. It's incredibly difficult to build a loudspeaker that both goes loud and has really good timbre. There's not many loudspeakers that actually, in my opinion, achieve that.
Speaking again of timbre, one of the biggest things that we see in terms of cinema and the way that people set up their cinemas from the marketing department, Spatial this week and this week only, the centered channel, which looks and sounds supposedly like the left and right tall boys, but it's completely differently designed. It looks different. It's in a different shaped box. It has a different drive.
It's the same parts,
No,
Christian. It's the same drivers. It's the same bits.
Cannot physically be.
I've read the brochure. It's the same bits. It's the same tweeter.
But it's applied differently. And that's the part that we, from an engineering perspective and from a measurement perspective, can actually realize and showcase and see and fundamentally make sure that we provide accurate designs and implementations of systems for end users so that they have that great experience. Timbre is also relative to the type of loudspeakers you use for your surrounds. If there's a glaringly obvious difference between the type of drive units used on your surround speakers and your front or main speakers, indeed on your overhead speakers and your Atmos channels, then you're going to have a very easy to differentiate panning object. It's going to go from left to right and around the corner, and you're going to go, oh, hang on a second. It changed completely. The color and the tone of that note that was being reproduced is changing. And our goal is to make sure that it doesn't. It changes at the least amount possible.
And a speaker that's designed to be used vertically. So let's take a classic speaker design, an MTM. So you've got a mid-woofer with a tweeter in the middle and a mid-woofer. You know, they're designed to be used vertically. They're designed to have really controlled vertical dispersion and really wide horizontal dispersion. If you take one of those speakers and put it on its side, it's a different speaker. Just because it's the same speaker does not mean that if you put it on its side, it behaves identically. It behaves completely differently and introduces lots and lots of artifacts. And we should probably have a show just talking about the evils of MTM loudspeakers used horizontally. You know, it's a terrible idea. Every speaker engineer will tell you it's a terrible idea. Every marketing and product development department will go, oh, but we need one of those in our catalog because it's expected. But yeah, when we say that the left, center, and the right speaker should be identical, as Christian said, not just from the same manufacturer, not just from the same model range, not just with the same drive units, but literally identical and identically orientated.
So the only way to get around that, I guess, is the acoustically transparent screen and 3 identical speakers. So we have to remember that has a compromise of its own. So I think either next week or the week after, we will have our first guest who's going to tell us all about those compromises. What happens when we put a screen in front of a speaker?
Oh,
that's a really
very
cool
exciting. And
that's
what a
we
guest.
Forget about.
What a guest.
What a guest. I mean,
you're not hyping up the next podcast by any chance.
I'm not sure I'm allowed to. I have to confirm what PR haven't signed off. So I'm not sure how much hype we can give yet, but
you actually have to put him in a paper bag. He's not allowed to put his face on the thing.
Cut the eye holes in the mouth.
Yeah.
And hey, we forget that there is a compromise. It's like with the speaker, you make one thing better, another thing gets worse. We choose 3 identical speakers. You've got to put them behind fabric at that point. They've got to go behind a screen, and that screen will have an impact. I'm so excited to talk
I would
about
question that, because as part and parcel of the compromise, the human brain is incredibly good at localization. And it was a topic that we covered recently on the RP22 calls. And it was a fascinating discussion where some amazing data was shared, and I'm sure it'll come out in due course. But all of it relates to your localization accuracy, and it relates to the movement of sound across the stage. And I mentioned panning a moment ago because that's one of the most common objects that we see, the smiley face below the television screen, which isn't necessarily a cinema. It could be a media room. It could be whatever you call it, an immersive audio experience. But getting those three identical and having a compromise for the actual visual device or the display is one of the challenges that is in the market at the moment, especially with the big OLEDs and the direct emissive displays that are coming out. How do you handle that panning from left to right? Because if the display takes up a lot of that space, yes, an acoustically translucent screen is fantastic, but it might not be to everybody's taste, or potentially to their requirement, or within the remit of their budget. And that's the compromise. Our brain is incredibly good at localizing that audio to link with the video signal.
So we've talked about dynamics. We've talked about timbre. We're 50 minutes in. Long one. Sorry.
There's a lot to get
I
out.
think we should start talking about spatial.
And that encompasses audience coverage, sound movement, like I've just mentioned, immersion and envelopment, which is an interesting one because I think one of the topics that we get asked a lot about as integrators, as designers, as suppliers, as manufacturers even, is how many speakers do I need? And where do I put them?
And all of this, you know, when we're talking about dynamics and we're talking about timbre and we're talking about spatial, all have to be related to how many of your audience do you care about? Are you talking about these things for one person? Are you talking about these things for three? Or are you talking about these things for all 12 in perhaps a 12-seat room? And the more people you have, in other words, the more of your room area is taken up by seating area, the harder the job is. And to me, that's the single hardest thing to do in cinema design, is to achieve a really fantastic result across multiple positions. It's quite easy for one, but it's the more people you have in the room, the harder it gets. So spatial, we've already mentioned them. Two main aspects. The first is immersion and envelopment. The second is localization.
Well, localization, I can go. Localization. Sorry, I didn't hear what you said. I was too close to the speaker. I'm sitting in the back left chair and you blasted my ear because the sound effect went over my head. And that's exactly it. We have a compromise in terms of room dimensions. We have a compromise in terms of how many people we want to squeeze into our little cinema. We have a compromise in terms of location of loudspeakers and types of loudspeakers. And again, in terms of dynamics and SPL and output capability of the loudspeaker combined with the power amplification, combined with the renderable channels that the processor or the AVR is giving us. And localization is exactly that. How and where can you localize the sound from? And we are incredibly good at doing that. Part of that test data that was shared with us showed that we are also, that not only are we incredibly good at localizing speakers on a horizontal plane around us to a certain angle behind us, but we are also very, very good at localizing them in the vertical plane.
So it's an interesting one that there's two ways that we're going to position a sound in a specific place in a room. One is we add enough channels and we keep adding channels till there's a speaker everywhere we need one, which isn't feasible in most rooms. So then we start to get phantom images, and we're all familiar with a stereo. The singer sounds bang in the middle. They absolutely sound between those speakers. The speakers themselves disappear. They may as well not exist in the room. And the orchestra or the band are spread out across a sound stage in front of us that you can position them. And that's all phantom imaging. What is happening certainly more and more with object-based audio mixes for movies is that phantom image happens between every pair of speakers. So between any individual pair of adjacent speakers, we can create a phantom image and put a sound there. So we can pan accurately with fewer. The more speakers we add, the easier that gets. The smaller the range that we have to cover with that phantom image, and the more accurately we'll cover it across all seats. But that phantom image is really kind of there's a lot of technical things that make that phantom image work. So phase coherence between speakers is massively important. And if we're using different speakers, even, we talk about them being identical, they have to be actually identical for it to work the best it can. If I take two speakers from manufacturer's range and they're just different sizes, the group delay might not be the same. The crossover design might not be identical. And actually, we've got slightly different phase characteristics from one to another, even though to all intents and purposes, they sound the same. They won't create a perfect phantom image that exists exactly where it should between two slightly different speakers. So we add more, or we make them more and more identical.
It's on that point you're saying, two speakers might need to be identical, but even if they are identical, they are not identical because they are placed on a different wall, in a different material, covered by a different fabric. Right. Close to or localized nearby a seat or a listener, which has an effect of harmonics and distortion and reflection, absorption, reverberation within that room. It is a proverbial minefield.
It might be worth just spending a minute talking about how we as humans localize something. So when we have our eyes shut and we hear something, we can instantly point to it. How do we do that? And the mechanism is really we do that in three ways. First, and the first thing to say is we have two ears, and they are positioned with a gap, with a head between them. Pretty obvious. Now that means that two things happen, and I'll explain the third later. And the two things that happen is where there's a sound. Firstly, it's probably going to be slightly louder in one ear than the other. So your brain processes that sound pressure level difference. And secondly, the frequency response is going to be slightly different because that sound is going to have to bend around your head to get to the other ear, and that changes its frequency response. And the third thing the brain uses is really, really clever, that these things on the side of our head, these bits of we call the ear, that's called your pinea, all of those ridges and shapes are very, very specific. And any of you with kids, when a child is born and you click your fingers, they're sort of looking around because they haven't learned how to hear yet. They haven't learned how their bodies work. As they figure things out and as they correlate, okay, sound level difference and frequency response difference, and they can see it and their brain learns, all of these ridges in our ears means that as the sound comes from slightly different angles and flows over those ridges, different frequencies are affected differently by the size of the ridges, and the phase response of that audio is actually changed by the ridges. And our brains learn that and use that in this processing. So sound pressure level is really important. You want it the same. Frequency response is really important because if two speakers have a different frequency response, that confuses your ears. And phase response is really, really important because if the two speakers have a different phase response, that's going to make, going to confuse the brain a bit. So all we have to really do is look at how our hearing system works to then understand what is it that gives us great imaging. And in the hi-fi world, people talk about, it's that the tweeter's made of beryllium, or it's this funky speaker design. And yeah, all those things matter. But fundamentally, to get really good imaging from a pair of stereo speakers, you need identical frequency response, you need really, really correlated sound pressure level response, and you need identical phase response. And this is going to be all of those things being broadband. If you can deliver all those three, you are going to have fantastic imaging because that's just the way our brains work.
I mean, that's your discussion of phase presumes that we've actually got the system accurately set up to start with. So phase would be a tiny micro shift in time alignment. But the amount of systems I've seen over the years where the correct way of setting the time alignment for those is just a distance. You put the distance of the speakers in, and they're not done accurately, or they're just done with an auto EQ microphone. And if you go back and measure the impulse response of multiple speakers, they can be out by milliseconds, and suddenly that phantom image has shifted miles. If one speaker plays a millisecond late, then our brain thinks it's in a different place. It understands that time difference has happened. So the localization is going to shift because one of the sounds arrived later. So even before we worry about phase, we've got to make sure that those speakers are actually time aligned generally by properly setting those up. And we can measure that. We can play a tone through each of them. We can record the impulse response. We can calculate the total group delay of when I hit this tone, how long does it take to reach the microphone? And that needs to be the same for every speaker. So we can verify that. We know that we've done it right when we've done it.
We tend to fall into the trap plenty of times as integrators where it's just, auto, set it up out of the box, press the button, it'll sound fantastic. And you're completely correct. The amount of times that you can go back to a system and you can tweak it and improve it it's not immeasurable. It's definitely measurable.
We're now over an hour. If I could just add one thing, we've covered a lot today, a lot of ground really quickly. If there's anything that you think that's really interesting, I want to hear more, leave a comment down below or send us an email, wherever it is, and we will endeavor to cover that in a future episode.
Without further ado, thank you very much, guys, and until next time.
Thanks, everyone.
Bye.